Nvidia announces the next generation of ultra-high-end chips, dubbed Blackwell.
The next big reinvention is probably where AI meets the physical world. And today, all of our AI experiences are related to digital.
Nvidia's new computer has sent a terrifying warning to the entire tech industry. At the GPU Technology Conference, Nvidia showed off its powerful new chips, aiming to take over the AI computing market. Many experts believe Nvidia is set to outshine Apple and Microsoft. Is this the start of an AI revolution that could change everything? Let us reveal the shocking truth about Nvidia's newest products and their plan to destroy any competition. The rise of Blackwell GPUs. Fans of the technology say the Blackwell GPUs are a major shift that could change how financial experts value tech companies. They suggest moving from traditional financial evaluations to a deeper appreciation of Nvidia's innovative products. But let's look past the polished presentations and get a clear picture of what Nvidia is really doing.
208 billion transistors, there's a small line between two dies. This is the first time two dies have abutted like this together in such a way that the two dies think it's one chip.
However, beneath the excitement of these product releases, there's a more complex situation. The Blackwell GPUs represent a significant technological step forward, with the potential to revolutionize data centers through improved efficiency and power. These GPUs are a significant financial risk, which could lead to either large rewards or substantial losses. Additionally, Nvidia's networking solutions, created to support these powerful data centers, should be examined carefully. Although they perform well in demonstrations, their effectiveness in real-world situations, with the varied demands of global industries, has yet to be proven. Consistent performance in real settings is crucial. The excitement surrounding Nvidia's stock also needs a critical evaluation. Predictions about it leading the market indexes and becoming a tech leader are based as much on optimism as on thorough analysis. This enthusiasm is similar to the early excitement for Apple's iPhone, which did result in significant profits for its investors. However, investments in technology are known for their unpredictability, influenced heavily by changes in market conditions and technological advancements. Nvidia is not limiting itself to just one area. It's ambitiously moving into multiple fields, including autonomous vehicles, supercomputing, humanoid robots, and digital twins for industrial applications. Each of these areas has its own set of challenges, from meeting regulatory standards to gaining market acceptance and dealing with competitors. Nvidia's expansion into these areas is bold, but it also exposes the company to various risks and depends on many external factors. In today's rapidly changing technology landscape, where giants like Apple once dominated, Nvidia is now stepping up, hoping to become the next leader. However, holding on to leadership in technology is always uncertain, depending heavily on continual innovation and changes in the market. There is also a strategic aspect to investing. Consider Warren Buffett's investment in Apple, which came years after the iPhone was introduced, yet it brought in significant profits. This shows that success in technology does not instantly translate to financial gain. Investors need to be patient and strategic, thinking about the long term. Nvidia has big ambitions to change the technology industry, but achieving this is not without its challenges. They face strong competition, constantly evolving market demands, and the unpredictable nature of developing new technologies. As Nvidia tries to push the boundaries of what's possible, it remains to be seen whether they will succeed or face obstacles that have brought down many others before them. Their latest product, the Blackwell B200, has generated a lot of excitement. Technology enthusiasts are keen to explore what it offers in terms of features and performance. It is said to greatly enhance processing power and efficiency, which could be beneficial in various fields like gaming and professional graphics design. However, the pace of technological advancement is incredibly fast, and yet, it seems never fast enough. The quest for more advanced technology continues relentlessly. Nvidia's earlier GPU, the Hopper, was once a top performer, but it now appears outdated compared to its new successors, the Blackwell B100 and B200. These new models are designed to meet our growing need for quicker and more efficient computing. Let's look closely at what Nvidia's recent technological developments actually mean. The new B200 chip is advertised as a significant improvement over its predecessor, the B100, with a performance increase of 10 to 25% depending on the type of work it does. It also uses a considerable amount of power, around 1,000 watts. When compared to the older Hopper model, the newer Blackwell chips are said to be 4 times more efficient at training AI models and 30 times better at AI inference tasks. The advancements are not just about adding more transistors to the chip. Blackwell introduces an innovative design where 2 semiconductor dies are combined uniquely, demonstrating Nvidia's ability to lead in engineering innovation. Where the Hopper had 28 billion transistors, Blackwell has more, each working more efficiently than before. Each time Nvidia launches a new GPU, it is presented as the most advanced and powerful GPU ever. This description often suggests that each new model is crucial, and that data centers and technology enthusiasts should upgrade to the latest model, even if what they currently have is still in good working condition. Nvidia's marketing strategy effectively generates excitement among consumers and investors, maintaining a steady demand for the newest technology. However, many of these upgrades may not be groundbreaking. They are often just small improvements. This continuous push for slightly better technology seems to reflect a general dissatisfaction with current technology, even when it is already advanced. The release of Blackwell, with its impressive specifications and promises of unmatched performance, makes us think about this ongoing cycle of upgrades. Is there a point where the drive for better and faster technology will slow down, or will the desire for more sophisticated technology always be present? Each announcement blurs the distinction between true innovation and just marketing the next big thing. It's worth considering how long we will continue to embrace the excitement and expense of these minor upgrades before we start to question their real value. Nvidia's new Blackwell chipset brings both big potential and big costs. Nvidia's vision for the future of data centers. Combining memory improvements and reducing disruptions in data storage, the Blackwell chipset has become a powerhouse of computing capability. Yet this level of complexity is not inexpensive. Despite these high production costs, Nvidia believes the exceptional performance of the Blackwell chip will offset these expenses. By setting a higher price for this powerful chip, Nvidia hopes to recover the high costs incurred during its production. In the fast-growing technology market, possessing the best equipment provides a significant advantage. Nvidia's plan is to dominate by supplying top-tier Blackwell GPUs to data centers and cloud services, aiming to become a crucial player in this rapidly evolving market. However, some view this strategy with skepticism. As TSMC, Nvidia's partner in chip manufacturing, continues to improve its processes, specifically the N4P process designed for Nvidia, it raises some questions. Could Nvidia keep its competitive edge by producing a simpler, less costly version of these chips? It's a crucial question for Nvidia, as it tries to find ways to reduce manufacturing costs while maintaining its strong position in the market. Keeping up with the market without breaking the bank is a perpetual challenge for Nvidia. This constant balancing act of integrating innovation while managing costs will significantly influence Nvidia's standing in the competitive tech arena. The tech sector has always marveled at the enormous computing capabilities encapsulated within tiny chips. Conversations frequently revolve around the remarkable ability of these diminutive devices to process vast amounts of data at astounding speeds, showcasing a technological marvel in miniature form. Attention often gravitates towards these compact powerhouses for their proficiency in data management. For instance, the introduction of the Grace CPU is celebrated for its ability to establish ultra-fast connections between chips. It's almost magical how such a compact unit can perform immense calculations, transforming the way data is handled across various platforms. The story then moves to the GB200 superchip. This chip is a mix of two B200 GPUs and a Grace server CPU, all linked together by something called NVLink. This setup lets the chip move data really fast, at a speed of 900 gigabytes per second. This is so quick that it can move the data of 150 full-length 4K movies from one chip to another in just about a second. Imagine moving huge digital libraries through tiny circuits that quickly. It's changing how fast we can move data. The tale also dives into high-stakes tech work in Silicon Valley, where people like Jensen are very important. Jensen showed off the GB200 superchip and a prototype board worth $10 billion. Holding the small but mighty chip in one hand and the big prototype board in the other, he showed what new tech can do today. The story also looks at new systems like InfiniBand. This system uses fiber optics to connect different parts inside a server, making it work better and faster. Then, Nvidia brought out something called Blue-field DPUs, which are different from regular CPUs and GPUs. DPUs are excellent at doing many things at once, like organizing, securing, analyzing, and moving data in this big network. Even with these cool demos and what they could do, people started to worry if these expensive tech wonders were really useful or just fancy tech to show off what companies can make. The GB model, called NVL72, is another big deal. It has 18 trays, and each tray has two of those superchips, linked by NVLink. Here's more detail. Each superchip has two Blackwell GPUs. These parts help move data fast. With two superchips on each tray and 18 trays total, that adds up to 72 GPUs all connected. That's why it's called GB200 NVL72. NVLink is not just a normal connector. It's a big step forward in how chips share data. It's made to work at speeds we once thought were impossible. But the tech world always wants things faster. Despite NVLink's speed, there's a push for even quicker ways to move data, leading to the creation of the NVLink switch. This thing is huge, not just in what it can do, but also in size. It's like a big GPU, has 50 billion transistors, and each of its 4 NVLinks can move data at 1.8 terabytes per second. It's not a small improvement, it's a huge jump, designed to meet the very top needs for moving data. Why do we need such a powerful tool? It comes from a need and the push to go beyond what we've done before, getting ready for future needs that might require moving even more data. The NVLink switch chip shows this drive, aiming not just to meet, but to go beyond what we currently expect, getting ready for situations that might not be common yet. Buying Mellanox shows Nvidia's push to stay on top. The hidden costs of ultra-fast computing. Nvidia spent a huge $7 billion to buy another tech company called Mellanox. This deal got a lot of attention in the technology world. Some people think it was a very smart decision by Nvidia, a well-known company in the technology industry. Nvidia added some advanced technology tools to its resources, including VLink, InfiniBand, and Blue-field DPUs. These terms sound complex, but they're important technologies that help computers communicate more quickly and effectively. Let's explain this further. In this system, there are groups of powerful computers called compute nodes. These are connected by 9 trays that each hold something called NVLink switch chips. There are 2 chips per tray, and each of these chips connects 4 powerful processors known as Blackwell GPUs. This setup allows each processor to talk to every other processor very quickly. It's impressive to think about how quickly these processors can communicate with each other. However, it's worth asking how necessary this fast communication is. While it sounds impressive that all these processors can talk to each other so quickly, it's important to consider whether this really helps most people or if it's just showing off technological capabilities. Moreover, while these technologies are impressive, they often come with challenges. They can be difficult to apply on a larger scale, might not be practical for everyday technology use, and usually introduce new problems that need to be solved. This discussion also touches on these technological advancements' broader issues and consequences. Nvidia's decision to buy Mellanox is notable because it shows how companies try to stay ahead in technology by acquiring new capabilities. However, the real success of such a purchase depends on how well the new technology is integrated and used afterward. If Nvidia can use these new technologies to make significant improvements, then the acquisition might be seen as a smart move. If not, it could be viewed as a lot of money spent with little benefit in the real world. The company positions itself at the forefront of technological innovation with the introduction of its latest tools. This initiative could potentially revolutionize the field or simply become another accolade in its extensive collection. As time progresses, the impact of this development will become clear. This subject continues to stir discussions and speculation about the future of technology. Their technological architecture: each NVLink chip is equipped with 4 ports. With 2 such chips per tray and a total of 9 trays, the system boasts an impressive 72 ports. These ports are integral to a network designed for ultra-fast GPU communications, handling an astounding 130 terabytes of data every second. This system, known as the DGX NVLink spine, claims a capacity exceeding the Internet's total bandwidth globally. Theoretically, it could distribute the entire Internet's data to every user worldwide in less than a second. Yet, one might pause to question the necessity of such vast technological power. While the figures are certainly impressive, the practical need for such extraordinary capabilities appears limited. The technology seems more about showcasing potential rather than addressing a clear market need. Would this level of performance ever be required outside of highly specialized technological research environments? Moreover, while surpassing global internet bandwidth in a controlled lab setting is possible, this does not necessarily imply practical, everyday utility. Such capabilities, although technically achievable, often lead to questions about the rationale behind such rapid technological advancements. Are these innovations driven by an actual need or merely by the capability to achieve them? Environmental concerns also come into play when considering the operation of such powerful technology. The world is increasingly aware of energy consumption and its impacts on climate change. The substantial energy required to run such a system prompts a reevaluation of its sustainability and justification. Is it responsible to deploy such energy-intensive technology without a critical need? The DGX NVLink spine boasted high-speed capabilities that were highly regarded in the tech industry, yet a closer examination revealed a disparity between these theoretical speeds and the practical data transfer rates experienced in real-world settings. The performance was hindered by several factors: the limitations of local network infrastructures, the slow pace at which data could be stored or retrieved, and the capabilities of the devices in use. Despite the impressive technical specifications, the actual need for such high speeds in everyday applications appeared overestimated. Most common software and applications would function just as efficiently with significantly lower speeds. Excitement often surrounded technological breakthroughs that pushed the limits of what was possible. However, these advancements' practical utility, costs, and environmental impacts warranted careful consideration. It was critical to strike a balance between pioneering new technologies and ensuring their applicability and responsibility in the real world. The GB200 NVL72 encapsulates 1.4 exaflops of AI training power within a single rack. An exaflop, capable of executing a quintillion calculations per second, was a measure of computing power that had once been exclusive to a select group of supercomputers around the world. Now, such formidable computing prowess was made more accessible by Nvidia. However, the necessity of such intense computing capabilities for average projects or users was questionable. Outside of specialized or extreme computing scenarios, the utility of such excessive power seemed limited. In the competitive landscape of technology, companies like Nvidia were compelled to assess whether their innovations genuinely met the evolving needs of users or merely amplified the specifications for the sake of advancement. The pursuit of technological excellence needed to be balanced with practical considerations, ensuring that the advancements were not only impressive in theory, but also valuable in practice. The GB200 NVL72 system is powerful, but comes with questions. The unseen giants of supercomputing. These powerful setups, each packed into a single rack and consuming 120 kilos of energy, are impressively strong. Each system includes an InfiniBand switch tray at the top, which is essential for linking these individual units into a large network of supercomputers. The idea that one can purchase multiple of these units and connect them to achieve even greater computing power is both intriguing and somewhat worrying. The rapid advancement of this technology prompts us to consider its impact on our world. Now, anyone who can afford it can buy substantial computing power. This shift dramatically changes the landscape of computational research and artificial intelligence development. Being able to process complex data faster and on a larger scale could lead to important discoveries in various fields. However, this impressive display of technological capability comes with significant challenges. These systems use enormous amounts of electricity. The environmental impact of such high energy consumption is significant, raising concerns about the long-term sustainability of such technological growth. Additionally, the ease with which one can increase computational power by purchasing more units raises concerns about technological inequality. The fact that only certain organizations or individuals can afford these high-end systems could increase the gap between those with access to advanced technology and those without. Moreover, the concentration of such powerful computing resources could lead to intense debates over control and access to technology, as more organizations might build their networks of supercomputers. Having so much computing power concentrated in a few hands could influence who controls important information, research capabilities, and overall technological dominance. In an age where technological progress races ahead at breakneck speed, a question looms large. Is this pursuit of advancement a genuine quest for improvement, or merely a competition for supremacy? Nvidia's relentless drive towards AI dominance starkly illustrates this dilemma. Envision a behemoth structure where 32,000 GPUs operate synchronously within a sprawling AI factory. This facility, with its astounding capacity of 645 exaflops, is not merely an enhancement of existing technology. It represents Nvidia's ambition to spearhead the realm of generative AI, poised to revolutionize human interaction with machines. Yet, one must ponder the motivations behind constructing such a formidable machine. What benefits does Nvidia derive from this venture? More importantly, what are the repercussions for society at large? A closer examination of such colossal technological undertakings is necessary to discern whether they serve a greater good or merely amplify corporate prowess. Previously, the acronym GPU was associated with a component that enhanced the aesthetics of video games. Today, it signifies vast complexes filled with potent devices that process data at speeds beyond human comprehension. This transformation underscores a significant shift in the role and magnitude of technology in contemporary life, simultaneously highlighting concerns about the sustainability of such rapid expansion. These data processing giants operate at unprecedented velocities, raising the question of the necessity of such extreme technological power. As Nvidia forges ahead, the need for such advanced GPUs becomes increasingly questionable. The essence of technological development should not solely focus on acquiring the most formidable tools, but should also consider the ethical use of such power. The race towards technological excellence often sidelines vital considerations like the long-term viability and ethical ramifications of these advancements. As Nvidia strives to outperform its competitors, it is imperative to evaluate whether such high-powered GPUs are indeed essential. Responsible stewardship of technology is crucial, ensuring it benefits humanity while mitigating adverse effects on the environment. The gaming industry is undergoing a profound transformation, one that is reshaping the foundational elements of society itself. This change is driven by the development of powerful technologies, particularly in the field of artificial intelligence. For instance, training a GPT model equipped with 1.8 trillion parameters capable of mimicking human thought and communication requires exceptionally powerful computer setups. These setups are indispensable for achieving such feats. However, as these machines become more sophisticated and begin to undertake tasks traditionally done by humans, it raises a critical question. Are these developments merely about creating advanced tools, or are they paving the way for technologies that could potentially replace human roles? At the forefront of pushing technological boundaries is Nvidia, a company that is testing the limits of what artificial intelligence and computing can achieve. This aggressive push into uncharted territories is fraught with complex issues surrounding economics and ethics. A key concern is the creation of a technology landscape where only the largest corporations have the financial power to compete. This scenario could potentially marginalize smaller companies that aspire to enter the AI field. Furthermore, the implications extend beyond corporate competitiveness into broader societal impacts. As AI technologies become integral to critical sectors like healthcare and finance, their influence becomes more pervasive, affecting every facet of human life. The technological power is undeniable, yet it brings with it profound considerations. One must ponder whether this technological advancement is setting the stage for a future dominated by a few powerful entities, effectively sidelining smaller, innovative players. The integration of these technologies into daily life and key industries necessitates a deeper reflection on their broader consequences. These technologies are no longer just tools for enhancing work efficiency. They are reshaping how people interact, live, and govern themselves. The potential of these technologies to revolutionize daily life is immense, but equally significant is the potential for dramatic shifts in the socio-economic landscape. Moving forward, it is crucial to maintain a vigilant and thoughtful perspective on the motives behind technological advancements and their possible outcomes. It is essential to weigh not only the benefits, but also the potential disruptions and ethical dilemmas that such technological progress might entail. Nvidia's new AI factory impresses, but also worries many. The rise of the AI giants, Nvidia's bold new era. Nvidia has recently opened a large AI factory, which is impressive because of its size and the advanced technology involved. However, this development also brings several serious problems. One major issue is the potential loss of jobs as machines start to replace human workers. Another problem is the decrease in privacy as these technologies become more integrated into our lives. Additionally, there is a growing dependence on complex systems that most people do not understand and cannot control. The introduction of such powerful technologies into our daily lives is not just about the technological achievements. It's also important to consider the broader impacts these changes have on society. These technologies offer both incredible opportunities and significant risks. As we continue to develop and use these powerful tools, we must remember the importance of being responsible with the power they provide. Many people are discussing this announcement because if the Blackwell GPU works as expected, it could lead to major improvements in how efficiently data centers operate, which could save a lot of money. Nvidia states that with the Blackwell GPU, a data center would only need 2,000 GPUs and 4 megawatts of power to operate, which could be a significant improvement over current technologies. These numbers are certainly impressive and seem to mark a notable improvement. However, they also prompt one to wonder about possible drawbacks that might not be fully disclosed. Nvidia is not just selling a new GPU. They are promoting the idea that Blackwell is a revolutionary platform that will not only enhance data centers, but also advance self-driving cars, smart factories, and even humanoid robots. They suggest that Blackwell has the capability to advance technology across various sectors. Yet, this broad range of applications might lead one to question whether a single technology can truly be effective across such different areas and achieve these goals quickly. Moreover, Nvidia proposes that this technology will be advantageous for both large corporations and small startups by offering more computing power for less financial and energy cost. For major players with large data centers and supercomputers, Blackwell is described as enabling them to accomplish much more without the need for additional space or power. Conversely, smaller companies might be attracted by the potential to extend their limited budgets in a highly competitive environment. Nvidia aims to appeal to a broad market by presenting Blackwell as a solution that meets diverse needs. However, this dual market strategy, while ambitious, raises questions about the feasibility of delivering on such broad promises. Is it realistic to expect one technology to meet such varied demands effectively? There might be hidden complexities or limitations not immediately apparent in Nvidia's optimistic projections. In promoting Blackwell, Nvidia paints a picture of a future where technological barriers are easily overcome, but one must consider whether these advancements are as straightforward as they appear. There might be underlying challenges or costs involved that are not being discussed openly. As attractive as these innovations may sound, it is essential to approach them with a balanced perspective, recognizing that significant technological shifts often come with unforeseen complications. The proposal from Blackwell aims to provide impressive features at lower costs, promising to attract a wide range of customers with their appealing price cuts. This is a crucial point because if Blackwell actually follows through with these bold claims, Nvidia's stock could not only increase but also become a critical part of any investor's collection, especially in an era dominated by advanced computing and artificial intelligence technologies. However, it's essential to maintain a grounded perspective. Despite all the positive forecasts floating around, investing in Nvidia remains expensive, with shares priced at around $900 each. This high cost makes it difficult for the average person to consider investing. Moreover, Nvidia's partnership with major companies like Amazon's AWS is significant. AWS might enhance its capabilities significantly by integrating Blackwell GPUs, indicating Nvidia's strategic move. This isn't just a simple collaboration. It's a strategic maneuver designed to ensure Nvidia's technology becomes more widely used, which is crucial for their success. Digging deeper into what Blackwell might mean for Nvidia and the surrounding community, it's clear that this narrative is crafted not just to highlight technological advancements, but also to uplift investor morale and capture public interest. The story is set to paint a future that closely matches the financial goals of the major players in the technology sector. What do you think about Nvidia's future in the tech industry with their strategic moves? Could this be a game changer? Leave your thoughts in the comments, like, and subscribe for more insights.